Hi everyone, my name is Davidien and I work at Texas Instruments in Dallas. Today we are going to talk about our new family of split-rail converters, their advantages, and the applications where you might want to use them in. You may be wondering what I mean by a split-rail converter. So for us, a split-rail converter is a dual output converter generating regulated positive and negative voltages from a single input rail in a single device. Engineers need positive and negative supply rails to power many analog circuits like op-amps, DACs, ADCs, and sensors, for instance, in various applications such as industrial applications, measurement equipments, automotive displays, medical equipments, and so on. So while there are many options for generating a regulated and positive-negative outputs, but many of these options compromise the design's efficiency, the cost, the solution size because they are using too many external components, or the ease of use. The family of split-rail converters from Texas Instruments aim to offer the best alternative for your plus and minus supplies. So let's have a look at a few examples of split-rail converters. So when it comes to converter solutions, most people typically use two DC-DC converter, a boost for the positive voltage and an inverting buck for the negative voltage. So when you use two DC-DC converter, you have an easy design and you have many reference designs that are already existing in the market. This setup allows individual regulation and asymmetrical output load. And you also have a pretty high efficiency because you are using two converters that are not linked together. So they operate individually from each other. However, the downside is that you have a more expensive solution, which requires not only two ICs, but requires external components and more PCB space. By integrating both converters in one solution, so one device, the split-rail converter TPS65130 eliminates the need for lots of external components. So this device optimizes the space and save cost, and the efficiency is about as good as for discrete solution, even when you're using low loads. So the TPS65130 is our only bipolar split supply for high voltages up to plus minus 15 volt and high currents up to 300 milliampere. This device has enable pins for independently turning on and off each rail. And we also have a Q100 version for automotive applications like infotainment and cluster. Another way to look at split-rail converters or positive and negative supplies using a split supply with a charge pump. It's a simple method. It involves a charge pump with a boost converter. However, you have downsides for using a charge pump. Most charge pumps are based on an unregulated voltage generation, producing poor output voltage ripple, about 100 millivolt or higher, and a poor load transient performance. Also, charge pump can support a limited output current and show some voltage drops at higher load. So while a charge pump solution is cost attractive, it has poor transient performance and has a bad solution size. However, if you're looking at our split-rail converters, you have the possibility to use a device called TPS65132, which is a single inductor split-rail converter with an integrated charge pump. So the boost converter generates the positive voltage that is regulated down by an integrated LDO. The negative supply rail is generated by an integrated negative charge pump driven from the boost converter. Both converters are regulated independently of each other, and the outputs are individually programmable between plus minus 4 volt to plus minus 6 volt, not necessarily symmetrically. Some key points of the TPS65132 are its high efficiency with a selectable power save mode. This device also supports 100% asymmetry of the output current. It comes in 12-pin CSP package and also in a 20-pin QFN package. It's fully programmable through I2C for the output voltages, and it also has enable pins for the sequencing. So let's have a look at the TPS65132 and how small the layout is with the device. So the first EVM is based on the TPS65132W, which is using a QFN package. So have a look at the size of the overall solution, how small it is. Then have a look at the EVM based on the TPS65132 in a CSP package. So, as you can see, split rail converters offer many advantages for many applications. You have high efficiency, flexibility, a small size, cost-effective solution, low space bomb, and many more. So let's have a look at the block diagram now showing all our devices for bipolar split supplies. This block diagram will enable you to identify the split rail converter that you can best use for your device. Also, I suggest that you visit ti.com/splitrail, our website focusing on our entire family of split rail converters. This family will meet your most complex power management requirements when you need a plus-minus power solution. Thank you.